Okay, so first of all, let's define probability. So probability means it's a chance in percent of an outcome to occur, of an event to occur, of an event or outcome to occur. So if they say there is a chance of 70% rain today, do you consider this high? Do you consider this low?
High.
Right. It's quite high, right? If we say there is a 10% chance of rain or snow, let's say today, low, obviously. So what is the probability of a certain event? Can anyone give us an example of a certain event?
Would that just be like 100%?
Yes, 1 or 100%. Very good. Can anyone give us an example? Are you certain that the sun will set today and night will come? Yeah, that's a certain event, right? What is the probability of an event that cannot happen, like impossible?
Zero. Or
Absolutely, 0 or 0%. Correct. I would like to define a few things and then look at an example. So first, let's define what an experiment is. It's a process that I can repeat, that can be repeated, but whose outcome is unknown. I don't know. If I flip a coin, that's an experiment. Do I know the outcome? I know the possibilities, but I don't know the outcome. If I get tails or heads, right? Okay, so flip a coin. I know I have two possibilities, either heads or tails. But on any time I repeat this experiment, I do not know the outcome. I know this is going to happen. There is nothing else. It's either this or this. But I don't know it on any trial. I don't know what the outcome will be. Okay. This is called the sample space for our experiment of flipping a coin. That's our experiment. And we can have heads or tails, and this is the sample space. What is the sample space? It's also denoted by uppercase S. So the sample space is a collection of all possible outcomes of an experiment. Stop me anytime if you have questions, please. So that's why this is our sample space, because nothing else can happen. There is no third or fourth option. Okay. So what is an event? An event denoted by E, and also we denote the probability of an event, probability of event E, is any subset of the sample of the outcomes of a probability experiment. So any subset of outcomes coming out of an experiment, when we talk about experiment, of course, we talk about the probability experiment. Probability, to be specific. It's a probability experiment. Because there are millions of different types of experiments. But we're talking about probability, in which we're looking for a probability. Okay, so by any subset, and I'll give an example in a moment, we mean maybe one outcome, maybe two outcomes, maybe three outcomes, or three events, or 4 events from the total. So let's also stick with this, so give an example here. So what are our possible events here? If we want to denote just a simple event, let's say event 1, which is simple event, just one outcome, only one outcome. Then I'm going to say that E1 is basically just getting heads. E2 is basically just getting tails. Simple event. Now, if I want to talk about all possible outcomes, which is the sample space, then I will say E1 and E2. Any subset in this case, because I only have, for the event, because I only have 2, I cannot say this with this, this with that, this with this, so because I only have 2. So let me look at another experiment. And let's identify for these, for the next experiment, we want to identify outcome, all the possible outcomes. We want to identify the sample space, and we want to identify any event we want. Okay, so let's say here's an experiment, let's say, of having 2 children. So what are the possibilities? Okay, the possibilities are a boy and a boy and a girl and a boy, in that order. These are different outcomes, and a girl and a girl. There is no 5th possibility. Yes, you can say twins and other things, or triples, etc., etc. So just let's assume that we are only looking at 2 children. We're not talking about twins or triples and so on and so forth. Just a simple experiment of test, and we remove everything else. Just 2 possible children. So either a boy and then followed by another boy, a boy followed by a girl followed by a boy, and 2 girls. Okay, so these are the outcomes. And this happens to be the sample space. Boy, 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 girl, girl, boy, girl, girl. This is the entire sample space, assuming that nothing else can happen. Okay, so a simple event, E1, is just boy, boy, for example, or any of these. E2 will be the next one, and so on and so forth. And then how do I write the sample space? Exactly, I can write the sample space as all possible outcomes, E1, comma, E2, E3, comma, E4. Any event that you want to pick is, let's say, E1 with E2. Okay? Now I can pick E2 and E4. I can create any event from any subset, just 1, or 1, 2, 3, or 1, 3, 4, or groups, any subset from the sample space. Okay, now let's talk about the rules of probability. There are only 2 rules. That's my page 3. Rules of probability. So rule number 1, the probability of any event, anything, it can be sample space, it can be anything, has to be a number between 0 and 1. Or if you want 0 and 100%, but anyway, when you add them up in these decimal numbers, they have to be between 0 and 1. And when we add them up, so the sum, if you want, of all the events has to be 1. If you don't like this notation, just remember that the probability of the sample space, something has to happen inside the sample space, that would be 1. Or the sum of all probabilities of all events has to be 1. So these are the rules of probability. So if I have A, B, C, and this one happening 0.1%, probability for A to happen is 0.1, this is 0.2, and this is 0.3, they do not add up to 1 or 100%. So this is not a probability experiment. It fulfills the first condition, but it does not fulfill the second condition. They do not end up to 1. So this is not a probability experiment. Number one, they have to add up to 1, and all numbers have to be between 0 and 1. Okay. So any probability model has to fulfill both conditions. Okay. How to find probabilities? Two different ways. One is called the empirical rule, and the other one is the classical method. What's the difference? And do we get the same thing? Okay. The empirical rule, I have to conduct the experiment. And after that, from here, I can determine the probability. Here, I only think. I don't conduct anything. I sit in my chair and think. And then from here, I determine the probability. Okay, so for our simple example of flipping a coin, let's say we flip a coin again, and I don't trust the classical method, or I just want to test the classical method maybe. So I want to I flip the coin 1,000 times. I record the outcomes. So I can have heads or tails. Give me any number. A number for heads, a number for tails, but they have to add up to 1,000. So any number you want. So I recorded the outcomes, and I got heads how many times?
50.
Oh, okay. So then you're saying that 950 were tails. Okay. Kind of difficult to fathom that, but who knows? It's possible. Anything is possible. So from my empirical rule, I know that the probability of the heads from my experiment is 50 out of the total. And of course, the probability for tails is 950 out of the total. Do the two probabilities add up to 1? $50 plus 950 is 1,000. 1,000 divided by 1,000 is 1 or not?
Yeah.
Perfect. So this is our empirical rule. But I have to sit here and flip the coin 1,000 times. Now, what will the classical method say? For the same experiment. So I'm on page 4. Classical. classical method says, I know that a fair coin will show tails and heads, and they both have the same chance of occurrence. The probability of this is, the probability of the tails is 0.5 or 50%, and the probability of heads is definitely 50%. It is possible that my experiment with 1,000 did not give me that 50-50 chances. It should have been 500 and 500. I didn't get that. So this is what happened when I used the empirical rule. But if I increase this number, and of course that's not possible, but if I increase it to a high number, by the law of large numbers, this will show eventually, assuming that it's a fair coin. Okay? So the classical method does not perform an experiment. We are just saying if the coin is fair. We know there are only two options: equally likely outcomes. They have 50-50 chances. So here we're just thinking. Okay, here's an example now.